Welcome to the DevOps webinar uh, from SkillUpRight. Today you are talking to Amit. There is Amit here. I have 16.5 years of experience in DevOps related technologies. I work as principal architect DevOps in my current organization. Yeah, and today we are going to talk about configuration management, and we will talk about how it is achieved using Ansible. Right? So this is agenda for today. So let's understand what is configuration management. In your DevOps landscape, DevOps pipeline, or the entire DevOps ecosystem, well, everything runs on servers, right? You have a server which is hosting your Git repositories. So let's call it as a Git server. You have your server which is running Jenkins instances, right? You have your build servers, or I would say build nodes. You have your Kubernetes cluster nodes, right? You have your what do I say, deployment machines. You have your development servers. In deployment, you can have production, you can have test servers, you can have staging servers, right? Many kind of servers. So all these technologies, all these tools, services are running on nothing but servers, right? Everything is server. Now, so many servers, how do you manage them? And this is kind of an operational topic, right? How do you manage large scale of servers and configurations, right? Let's say you are a team which has started um, using these tools like Jenkins and Git and everything, and you go to your IT and say, hey, I want 5 servers or 6 servers. They give you 6 servers. You have 1, 2, 3, 4, 5, 6 servers, but then you have to configure them. For example, on Git server, you want to install Git or GitHub, right? Then you want to create some access permissions, right? You want to manage some configurations. Okay, on Jenkins you want to install Jenkins. Well, Jenkins is written in Java, so you may also want to install Java. So you want to install Jenkins, you want to install Java. Again, access permissions, configurations. Similarly, on all these servers, you have to do certain kind of configurations so that the server is able to serve the needs that your team has. Right now, doing this configuration for all the servers is a tedious task. And if you have hundreds of servers, then it's almost impossible to manage those manually. So you need some sort of automation on managing those servers. So what can you do? Well, to solve this problem, we have a concept which is known as infrastructure as code, right? We should call it that infra configuration as code, short for IAC, infrastructure as code. So what happens here is instead of manually managing the server configurations, you use a tool. You use a tool, let's call it as a configuration management tool, right? This tool has the capability to manage the configurations of a server, right? So for example, you have, let's say, 3 servers. 1, 2, and 3. You have three servers: server 1, server 2, server 3, and you want to manage them. For example, on server 1 you want to install Git, server 2 you want to install Jenkins, and server 3 you want to install let's say kubeadm, right? On server 1 you want to create a user, for example, uh, Git user, let's say. On Jenkins you want to create a user called admin, and on Kubernetes this server you want to create a user called kube, right? Then you want to manage some files on this server, some files on this server, some files on this server. So you want to configure these servers according to your needs. Instead of manually configuring the servers, manually taking the actions to perform yum install or apt install for Git, then user add for managing the user, you would like to do things automatically. So what you do is you use a configuration management tool and you connect these machines to this configuration management tool. You enable this tool to talk to these servers. If you have more servers, you enable connectivity to all of them. Yeah. And then whatever configurations you want on these servers, you define in a state file. Okay. Also called as sometimes manifests, sometimes playbooks. But the generic term is state file. You define the state of the server that you want it to be in. You want the server S1 to be in certain state. You want the server S2 to be in certain state. For example, S2 should be in a state where Jenkins is present, Java is present, and user admin is present. So you write all these desires in a state file. And in this state file, you say, well, for S1, I need this, this, this. For S2, I need this, this, this. For S3, I need this, this, this. And you feed this state file to this configuration management tool. And this tool passes this file, understands what's the desire, and then tries to realize your desire by configuring the servers according to your desires. Okay? So here, y- the entire configuration of the server is written as a piece of code here, right? So this is a piece of code. So your entire server configurations, your entire infrastructure's configuration is written as piece of code. And that piece of code is understood by a configuration management tool and then applied so that the server can reach the desired state, right? So there are many configuration management tools. For example, there is Ansible, which we are going to talk about today. There is Puppet, there is Chef. These are the main popular tools. Then there is CF Engine, right? There is, for AWS, there is OpsWorks. There are many tools like that, right? So all these tools solve the same problem, but in different way. Okay. So today we are going to see how Ansible works and how it enables us to solve this problem. All right. So let's build upon this architecture diagram to talk more about Ansible in detail. So Ansible is written in Python. So Ansible is going to be our configuration management tool, and you have to install Ansible on a separate server, right? So this becomes your Ansible server, which has Ansible installed, and you enable SSH connections to all the nodes that you want Ansible to manage. Okay, so this server should be able to SSH to S1, SSH to S2, SSH to S3. Now, if you don't know what is SSH, well, you can spend some time learning about it. SSH stands for Secure Shell. So SSH, so secure shell, and it enables the source machine to gain a shell or a terminal remotely onto target machines. So that's what we are doing here. Okay. So Ansible server talks via SSH to these machines. These machines are called as hosts. So this is a host. Let's call it as host 1, host 2, host 3. Right? So Ansible calls these servers which you want to manage as hosts. Now these state files are called as playbooks, right? And the format in which these state files are written is YAML, right? YAML is a evolution of JSON. So yeah, if you don't know what is YAML, how it is written, well, you can watch other tutorials or you can read about it internet. We do not have much time to discuss about YAML, but yeah, this is the standard format to write your playbooks. You can also write your playbooks in JSON, but YAML is most popular. Okay, now how does Ansible work? Now Ansible takes this playbook and then sees, well, what is the configuration desired for S1, parses that configuration. Let's say this configuration for S1 says that on S1 Git should be installed, right? And the user add Git user should be present, right? These are the two configuration requirements from S1. So this Ansible server now will connect to this S1 machine using secure shell or SSH and perform whatever actions required to get this configuration done, so that finally S1 will have Git installed and Git user to be present. Okay. Now, how does Ansible achieve that? How does Ansible get this thing working? Well, Ansible internally uses something called as modules. Modules are small binaries, generally written in Python, and they are actually the low level workers which perform system level changes. So you can use a module, or you can use a module called user, which allows Ansible to manage users, right? So when you have this configuration where Git user is supposed to be present on S1, Ansible is going to use a user module called user and send this module over via SSH to S1, and then give this module all the configuration information required to make the changes on the server. Okay, so to summarize, in the playbooks, let me use a highlighter. Yeah, in the playbooks, we define the state of the servers, right? This playbook is fed to Ansible server, and the Ansible then takes these playbooks, identifies what's the requirement, and then uses external programs or small programs called as modules, send them via SSH to the corresponding machines, and make all the configuration changes on those machines. So at the end, you write your playbook, and when you execute the playbook, at the end, you should get Git installed here and Git user created here, right? Now, how does Ansible know which machine it has to manage? So that information is maintained in an inventory, right? It is again another configuration file which contains information about what are the hosts that Ansible is supposed to manage, and many other configurations like how to connect to them. Is it a local host? Is it connection via SSH? What should be the remote username to connect? And yeah, all other information. So this inventory is also fed to this Ansible server all the time. So you can write playbooks and you can write these configurations only for the host that Ansible is supposed to manage. If there is another machine called as S4, but in the inventory you do not have information about it, then you cannot write any configuration for S4 in this file. Ansible will say, don't know what is S4, right? So this is how Ansible works. Now let's utilize the remaining time in understanding or in demonstrating this functionality. So what I'm going to do, I'm going to set up 3 machines here. So I will use one machine as server and other 2 machines as 2 hosts. And then we'll try to configure them using playbooks. Okay, so I'm going to take 20-25 minutes for this demonstration, and last 5 to 10 minutes we will try to take up some questions. Okay, so give me a second. Let me start some instances, and I will start sharing my screen again. Just 1 minute, maybe. Can you see my terminal now? Okay, good. So now I have some machines. I'm going to connect to them. I have set up these machines on AWS just for this purpose. Yeah. So here I am on this machine, which is our master. Okay, I'll be root here. Then I'm going to connect to 2 other machines, which are going to be our host 1 and host 2. This is host 1. This is host 2, right? So the idea is we are going to use this machine as our Ansible server. This machine as our Ansible server, and we will manage configurations of these two machines. All right. First thing is we need to install Ansible on this. Now all the machines are based on Ubuntu. Okay. All the machines are based on Ubuntu 20.04. So if you have Ubuntu machines, these commands should work. If you have AWS, these commands should work. So I would say apt install. First thing I will do is apt update. So this is to build up the cache of the packages. Then I'll say apt install Ansible. Simple. Ansible is available as an installable package here. So now you can see a lot of Python related binaries are also being installed. Because Ansible is written in Python, it needs all this, all the Python dependencies. Ansible is installed. So if I run Ansible, I should get some output, right? Cool. Now we need to, if I go back, or if you remember the architecture diagram, we need to have an inventory file which contains about information about our hosts, right? So let's create an inventory file. Now that inventory, if you go to /c Ansible, this is a place where Ansible looks for all the configuration files. And here is a file called hosts, right? So I'm going to open this file. This is our inventory file. And here you can specify which machines you want to manage using Ansible. So here are a lot of examples, pre-built examples, how you can write your inventory. I'm not going to go through all of them because we don't have enough time. But what I'm going to do is I'm just going to write some inventories here. For example, this is one machine which you want to manage, right? So I'm going to say um, this is the IP address of the machine I want to connect to. So this is one host which I want to manage. And this is another host which I want to manage. So these are the two hosts which I want to manage. We can give them nicknames. We can have more configurations for each of those hosts. But for now, I'm keeping things simple. Done, right? Saved. If I print the host file inside etc Ansible, at the end, I will see these two entries. All other entries are examples and are all commented out. You can see all entries begin with hash. So that means they are commented out. Now let's test it. I'm going to run one command, Ansible all -m ping. So what I'm doing here is I'm running a module. You remember modules? Modules are external programs which allow you to or allow Ansible to make changes on the system, right? So I'm using a module ping, which actually does not make a change to the system, but it talks to the host and gets some response. Basically, ping is used for testing if the hosts are up. So I'll say Ansible on all hosts run this module ping. So I want to get response from all the hosts. I'll press enter and I should get errors. You see, I get some prompt that it is trying to connect via SSH to these machines. and it wants my input here. And it says error. Let's run this command again. And it says error. It says failed to connect to the host via SSH, permission required, permission denied. So what does this mean? This means that, as I mentioned, the Ansible server has to connect to the host via SSH, and we have not set up SSH based authentication. So now let's do that. I'm going to generate a key pair. SSH-keygen is the command which allows you to generate key pair, and by default, doesn't matter in which directory you run this command, it is always going to create the SSH key pair inside your home directory /.ssh. Okay, so it shows me that it's going to create a key pair there. Now again, if you are not aware of SSH and the key pair and passwordless SSH, you should read about it. You should know it already. If you don't, read about it and then watch the video again, right? Okay, so SSH keys are created. Let's go to our home directory and let's go to .ssh in our home directory. Here, I see that there is a private key and a public key created. So I want to use this private key to connect to the remote machines, all these machines. But to accept the private key, I have to publish my public key on both these machines. So what I'm going to do is I'm going to print this public key. This public key is safe to share and you can share it with anyone. And in the target machines, in the .ssh folder, there is a file called authorized keys. In that file, I'm going to paste it. So I added my public key here, right? And then save it. As simple as that. Similarly, I'll open .ssh authorized keys, and here also I'm going to paste it and then save it. That's all I need to do. Now, when I run this Ansible ping module, Ansible is going to connect to both the machines and get some response. So it says for ping, there's a response pong. For ping, there's a response pong. That means machines are reachable, right? So what did we do? We set up a passwordless SSH from Ansible server to the host that we are trying to manage, and then um, enable communication between them. This way of running modules, like I ran the ping module. This way of running this way of running modules is called as an ad hoc command, right? You can run other modules also. For example, I can say Ansible on all hosts, run a module called as user, right? Run a module user. So what does this module do? This module manages users. So I can say run this module user and ensure that user name demo user has a is created. I say that execute the user module on all the machines, and this is the parameter or inputs to the user module. Name demo user, state present. So that means ensure that the demo user is present on all the all the machines, all the hosts, right? Let's see if this works or if it gives us an error. Compile. I'm user. Right. Yeah. So name, demo user, state present. So this is a way by using which I executed the user module on the machines, and I managed a user called as demo user, ensured that it is available on all the machines. So the output says something has changed, right? It says that changed, the user now exists. I can go to those machines, any of those machines, and I can say ID demo user. Check the identification of demo user, and for sure, you see a demo user is created. If I print the etc password file, you will see a demo user is created, right? It will be on the other machine also. So just by running this command, we were able to manage a configuration of all the systems. We can also say, well, on the same lines, we can say ensure that demo user state is absent. And just like that, Ansible will delete the demo user. If I print the etc password again, you will see demo user is gone. No such user, right? So you can run ad hoc commands to manage resources on the fly, right? Ad hoc commands can be run on all the machines or on a single machine. So you can say Ansible and then machine name or machine IP address, for example, 172.31.47.5 -m user and blah blah blah. So then this module will be run only on this machine, not on all the machines, right? So this was a way to run ad hoc commands. But then again, I did not mention anything about ad hoc commands in the architecture. I mentioned that you write state files, the playbooks. The playbooks are the files which will have information about how to manage your entire infrastructure, right? And that file can be documented, so you can check it into Git repository or you can store it at some other place where you can refer to it later. Unlike ad hoc commands, which once executed are lost, right? So let's write a playbook. So I'm going to go back to etc Ansible, and here I'm going to make a directory called playbook, playbooks, right? Let's write a playbook to achieve our initial configuration. On this machine, we will install Git and create Git user. On this machine, we will install Java, let's say, for example, right? We'll not install Jenkins, but we will install, or we can install Jenkins also. We can install Java also. Okay, let's do it. So I'm going to write one playbook. I'll say master playbook. Now this file is in YAML format, so I'll give it an extension YAML. So when you write a playbook, you have to define on which host you want to run, right? So I'll say host. I want to run this playbook on the host 172.31.47.5. This is my host name on which I want to run this or define this configuration. So for this host, I want to define my configurations. Okay. And the configuration will come as tasks. I want to define many tasks. So first task is, I'll give task a name, install Git, right? And then which module I want to use to execute this task. There's a module called apt. And in this module, I can specify name is Git and state is it. So I defined a task which ensures that Git is installed on this machine. So I give it a name called install Git, and then I use module called apt. There's a module called apt which allows you to install packages on Ubuntu machines. So since my machine is an Ubuntu machine, I'm using apt module, and I give it some parameters. Git present. It is similar to running ad hoc commands, right? User and then username and state. So we had one more configuration for this, which was ensure git user exists, right? Then user is the module I want to use, and I will give it a name. Let's say git user that we want to ensure exists, and state is present. That's it. Maybe I'll change some format here so that everything is in line and more readable. This is all YAML format. Now I want to have Java installed on the other host. So I say 172.36.233, which is this machine, another host. I want to install Java. I want Java to be installed, Java 8 especially. So I'll say open JDK, which is the package name, 8 JDK. Ensure that OpenJDK 8 JDK package is installed on Java, right? Also ensure admin user exists. So there is another configuration requirement that on this machine, admin users should exist. Admin user is present, right? Now let's verify. Does git user exist on this machine already? I'll say ID git user, no user found. Similarly, does Java exist on this machine? Let's say Java version, Java is not found, right? Also, is admin user available on this machine? I say ID admin, admin user is not found. Okay. Now, on all my machines, I also have to update the cache, right? Apt update has to be run. So there is also one parameter here, update underscore cache. I will say yes, please update the cache as well, which is nothing but apt update equivalent. So now this playbook is written. This is our play file, or this is our state file. Now I'll say Ansible playbook. This is a command. Ansible playbook. Run the playbook master playbook.yaml. Press enter. Ooh, it's an error. Line 12. Let's see. Oh, okay. There's a problem. I should have added this, right? And also there is supposed to be a name. Name is manage host 1, for example. And here could be a manage host. Hmm. Name host tasks. Just give me a second. Let me verify. strange. Okay, let's remove it. Alright. Okay, okay. Yeah, YAML is a bit weird in this syntax and indentation. Let's see if that was a problem. Yeah, okay, that was a problem. So now you can see it is running the manage host 1 configurations. So it is first connecting the complete information about this host. Then it's going to execute the next task, which is installing Git. Done. Then it's going to ensure that Git user exists. So it changed something here. So it looks like Git was already present on that server. Uh, and then it changed something to get Git user on that server. Now on host 2, it is gathering some information. Then it's going to install Java. And at the end, it's going to install or manage admin user. So while it is running on this machine, I can say id git user. So this should exist now, and git also exists. So Java is a big package. It may take some time to install. Yeah, so at the end, we should get our servers configured as per requirement. Any questions till now? So now you can see Java is installed. So something was changed on the system, and admin user is also now available. So on this machine, if I say id admin, admin user is available, Java version, Java is also installed. Just like that, we were able to install a version of Java and a machine and a user on the machine. Now, even if someone deletes this user by mistake, let's say user del admin, somebody deletes a user, yeah, admin user is deleted. If I run my playbook again, Ansible will realize that, hey, okay, the user does not exist anymore. So let me create that user, right? So this is how Ansible will ensure that a system remains in consistent state. Question, is there a way to make this work simultaneously? Like second machine waited until Git was installed on machine one. Yes, so if you have um, multiple plays, okay, so each of this configuration was a play. This is play number 2 and this is play number 1, right? These are called play. That's why it is called as playbook, book of plays. So this is play number 1, this is play number 2. So each play is executed sequentially, and each task in the play is executed sequentially. You can make it run in parallel also with extra configurations. If you change for one machine, then it will run for all machines again. No, as I showed you, if we run it again, then it does not change if something already exists on the server. Can I parameterize host IP? In the playbook, no. Is there a way to make this work? Okay, this is answered. How was did set up the environment variable of Java? Well, it is part of the aptitude package. Where does Ansible get packages from? Can we install custom programs? So app module will get packages from apt repository, canonical repositories. Is there any Ansible component installed on the host that are to be managed by the Ansible server? Nothing is installed on the host. What is state present and what else states are available? Okay, good question. So what are other states available? So we can go to the documentation. If you check the documentation online, maybe I'll show it later, but we don't have time. If you search for Ansible user module documentation, you will see what are the attributes available. For example, we have used name and state, and for app module we have used name, state, update, cache. There are many other options available, and for each parameter there are many values available. For example, for state you have present, you have installed, you have pruned, you have deleted, you have absent. Like many options are available, so you can have the entire documentation on Ansible's website. How do we used to do it before configuration management tool? Not manually, I believe. So we could do manually or write scripts, right? You can write a bash scripts or Python scripts to manage this, which was not very efficient. How about for Windows servers? Does these commands change? Oh, Windows server can also be managed by Ansible. I forgot to mention that, but there will be some different commands and different ways to connect to the server, right? So connection from Ansible server to the host is not via SSH, is via WinRM, Windows Remote Machine. That's a different protocol, and the modules also change, right? So app module cannot be used there. So the modules are also different. Where do manifest files reside and how are they triggered if there is a change required? That has to be done externally. So you can have a Git plugin or a Git hook where you check in your playbooks in the Git, and as soon as playbook is changed, it will trigger Ansible. How is Ansible different from its alternatives at high level? For example, Ansible is a push-based configuration management tool, so all the configurations are pushed to the host. Puppet, on the other hand, pulls the configuration. So there is an agent running on each host, which talks to the server and pulls the configuration. Right. So that is push based, that is pull based. Also, the protocols are different. For example, Puppet uses HTTPS or SSL for communication. Ansible uses SSH. Then there are small differences like formats and syntax and things like that. Instead of IP, can we have domain name? Yes, you can have domain name. Okay, I'll take three more questions and then we will stop. How many modules are available and where can I get all the details? So look for Ansible modules documentation. Ansible has extensive documentation available online and you can see all the modules available. While executing, if server 1 gets stuck, how Ansible tool will get to know and move to the next server? So there will be a timeout. If server 1 gets stuck, after timeout, it can say, okay, cannot execute command and move on to the next server. Does the host downloading the config files? Which config file do you mean? If the host is busy or not available, will Ansible attempt multiple times? So yeah, internally it will attempt couple of times, but then it will time out eventually and then give up and move on to the next. Is it necessary to have knowledge of Python to start using Ansible? Absolutely not. Python is written in sorry, Ansible is written in Python, but you don't need to know Python. Best tool, Ansible, Chef, or Puppet? Very difficult question to answer. It depends on use case. If you are starting, if you're a beginner in configuration management, then the best tool will be Ansible to start with. But is it the best tool to use? Well, that differs from people to people, organization to organizations, and need to needs. Okay. So with this, I will conclude today's webinar. And thank you for your attention. Thank you for the opportunity given to me to attend my session. And I will see you next time. Right? You will have the video recordings available to you. So the SkillUpRight team will reach out to you with the recordings, or they must have shared with you already the process to get the recordings. And please join our future webinars as well. Thank you, and take care. Bye.